The third industrial revolution began in the late 1900s, and one of the main characteristics was the use of electronics and computers to digitize and automate the manufacturing process. While automation has led to increased output, more consistent products, and 24-hour manufacturing, it does have one small problem. The computer will only do what it's told to, and this can lead to energy being wasted by manufacturing equipment being left on when no actual manufacturing is occurring, simply because the machine does not know nothing's happening. If we could collect runtime data of the machine, we would be able to find areas of the dead time when the machines are running when they necessarily don't need to be. Our solution aims to collect this data from the Programmable Logic Controllers, also known as PLCs, without disturbing the manufacturing process. This is our solution. It is a Python-based GUI that runs in the user's browser. The first field is the file name. This is whatever the customer wishes to name this test. After hitting go, it will check in the folder if there are files with the same name. If there are, it will import them to run a previous test. If there aren't files already created, it will create them. The next line is to create PLCs by entering the IP address and a nickname for the PLC. Multiple PLCs can be added and tested in the same test. The next line is where tags are entered. These are the variables you wish to observe. You enter the IP address or nickname of the corresponding PLC and the corresponding tag name. There are also fields for horsepower and RPM for motors. The last line is for a stop tag. This is an arbitrary tag created inside the PLC program to stop the test. Once all the variables are configured, hitting the run button will begin the data collection. This is one of the PLCs we used for our testing. Currently, the only variables we are watching are the statuses of the three LEDs at the top. This simulates signals turning on and off. Pressing the red button triggers our stop tag and ends our test. Back onto the computer, the output file is saved in a CSV format that can be directly looked at or used with the simulation tool being developed by another team. The main conclusions from our development and testing of our system is that it takes a single person less than 1 hour to set up the system initially. The data collection is fast and accurate. It does not require physically altering the PLC to use our system. The next steps of this project would be to integrate our system into the other team's simulation tool or vice versa. Further refinement of the GUI to include more reactive features and additional functions. And lastly, creating a bash file that can assist in installing the libraries required for our system.